Você acha que dá pra escutar? Tá. Tá. Tá, porque eu acho que ela tá também pegando. Hey, hi.
Hey, hi. My name is Cynthia. I'm just a today, and I'm activated here.
You're here at Fórum.
My name is Anna.
I'm a
Here at UAE.
What's your semester?
You're in the
Third semester.
I'm a master student now on civil engineering here at UAE. Educação em engenharia foi base minha, my thesis.
Mas tu co-advising.
Yes, Mahmoud.
Oh, really? He's the one who studied the shells, the substitute for cement.
Okay. Great.
My name is Felipe. I'm a civil engineer, and I just started last semester with Professor in
Felipe, I've been telling him that I wanted him to use the index that I forgot the coordinator at the construction management. His name is Paul. I forgot his name.
Paul Godreau?
The coordinator of your
John?
Fórum.
Paul?
John. Yes. An index that we could analyze the project to figure out if they have some problems in construction. And he was studying the causes of delays in public work, especially I think infrastructure projects. So we want to use that index to see if it's applicable to the projects in Brazil. So
Okay.
as the other student.
Okay, great.
Hi, my name is Daniela. I'm a civil engineer student. Nice to meet you. Eu acho que meu microfone tá.
Você falou?
Eu sabia de nenhum.
Deve ter uma.
Did you hear Dani speak?
I don't hear everybody, and I hear echo.
Porque o meu microfone tá ligado.
Maybe if we leave only one computer on, maybe that will help, like with the microphone.
Ela tem tradução e vai pro YouTube. Aí ela tem som.
Não, eu queria
See if it works. It's working now.
Okay.
She's in the 5th period, and she was organizing this conference. She was one
thank you. Okay.
This Professor Marcia.
Yeah, I hear Amelia because you're close to the computer, I think. Yeah. Hi. Hello. Nice to meet you.
You can present yourself, Marcia. She's a professor here that works with GIS.
Okay.
She's from the transportation area, but I'll let her present herself. Say everything.
No, it's not everything, I'm sure.
So welcome everyone. It's really a pleasure. I met Svetlana in November when I was at CSU. And we became like she's such a kind-hearted person. As I found a sister at CSU, and everything I went to a couple of her classes, and she's been an expert in graphics and lean, and she also teaches augmented reality. So she can talk a little bit about her specialty, and I went to a class about construction, and she's very didactic, and she brings all these materials to the classes. She starts her classes with music. I wanted to do that, but I think no one took me seriously when I said it. At the beginning of the class, she actually she asked for music questions that common around. It was really a pleasure to understand deeply about it. It was very interesting to see in the lab work, the students having like problems, texture, some people, they're all, you should have known this happened. It was very enlightening for class. So Svetlana, my dear, I'll pass the word to you. And
Thank you, Emilia.
Thank you.
Yeah, and I was thinking to have this as an interactive class as much as possible. So if you have any questions, please interrupt me. If you want to share your experiences that they relate to what we are talking about, please just jump in. So I will start sharing my screen and let me know if it works or it doesn't work for any reason. These are my PowerPoints, and I need to go back because I was trying to open some videos. So I appreciate Emilia already made introductions, but now I would like to introduce myself, and then we're going to focus on these different topics that I plan to introduce to you during the lecture. So what are the construction activities that could be done differently in sustainable buildings as compared to conventional, traditionally built projects? And I asked Emilia if you're familiar with the rating systems, and she mentioned that you have heard of LEED, so I'm going to touch on LEED a little bit and a couple of other rating systems, and then focus really for the majority of the part on the construction phase and how we can integrate some sustainable practices during construction. So Emilia created a really nice flyer that talked about my background. So really I started in architecture. I did my bachelor's at University of Belgrade in Serbia. It was Yugoslavia at that time. And then after I finished my undergrad, I'm like, I just want to work. I never thought I'm going to be in academia one day. So I worked for a couple of construction companies. The first one focused on commercial buildings for a couple of years. And then I got a job in the company that was a subcontractor on installing curtain walls. And curtain walls are those all glass walls that you will typically see in commercial buildings. And it was very unique and interesting experience. And I did it for about 4 years. And then economy was not that great in Serbia at that time. We had a recession and not much work, and I decided to go back to University of Belgrade, and that's how I started teaching. And at the same time, I was doing masters, and my masters focused on sustainable design and construction. So that was in 90s. It was kind of new topic. And then I taught for about 6 years in Serbia, and in 2000, almost 23 years ago, I moved to the United States and did my PhD in construction management at Virginia Tech. And when I completed my PhD, I moved to Florida. And in Florida, I met a lot of Brazilians. I think I mentioned to Emilia that, and that's where I still have these connections, very good friends from Brazil. And I taught in Florida for about 11 years and then moved to Colorado 8 years ago. So that's my journey. That's where I'm at today. I've been teaching classes related to construction materials and methods and what we call graphic communications in construction that include manual drafting and AutoCAD and Revit, which is building information modeling tool. And I also teach a couple of sustainability classes here at Colorado State. And I taught study abroad sustainability class in Costa Rica. So that's about my teaching. And for research, like Emilia mentioned, I did originally started in sustainability during my master's, and it has been my research area. But about 15 years ago here in the States, we saw more implementation of BIM in industry. So I started teaching BIM in classes and also doing research with grad students in the same area. And normally it's BIM and sustainability, or BIM and safety, or BIM and project management. So really anything that relates to BIM I'm really interested in researching. Here on the slides, you can see a couple of slides from my graphic communications class. And about 5 years ago, we decided to apply for a grant and get some money to buy 5 VR goggles and set up this lab where our students can come and put the goggles on and then look at their projects. They design a little house. They're not designers, they're construction management students, but they do design a little home to understand what designers go through and to understand the constructability of the home, and then they're able to see it in the virtual reality environment. When Emilia was visiting us, we were trying to make it happen, and I think George actually tried it. It happened, so that was great news. So that was one class, and then in construction materials and methods class, I asked students to build a little structure that simulates wood frame building, but we made it of these plastic components. And this student here is wearing a HoloLens, which is augmented reality goggle that basically overlays digital model with the classroom. And then they're looking at this digital model and they're building this little structure of the digital model. And then some students build it based on two-dimensional drawings. Some students use virtual reality. So we wanted to see if there is any difference between learning based on two-dimensional drawings versus virtual reality. And we found that virtual reality really, and augmented reality really engage students much more. They find it fun. I think this is Julia, I'll admit her. And anyways, that's my major research recently in virtual and augmented reality. And then here on the left side, you can see a worker working on the scaffolding. So here in the United States, construction industry is the second industry in terms of fatalities, unfortunately. A lot of workers die on the construction sites. And when you think about major cause, fall from the heights is responsible for about 1/3 of deaths. So I have been doing research in safety too to ensure that our workers are going back home after their work there, and it's a huge impact on their lives and their family lives. So I'll stop here, ask if there are any questions about me before we move on to the actual lecture.
I got curious. Which one is the
Wait,
first?
a couple of seconds. No, I don't hear Emilia. I think because we are muting and muting, and it worked great. This muting works because there's no echo, but then we will need to switch, I guess.
I got curious to know what is the first industry that most kills people.
My first industry experience, yeah, it was.
The one that, because you said construction is the second that has most fatalities. What was the first industry that has most fatalities?
Oh, the first industry is agriculture. Yeah.
Thanks.
Yeah, I see what you're asking. No, that's fine. That's fine. Thank you. Okay. So I mentioned earlier that we can do simple approaches when we want to be sustainable in a construction project. And some of them we already implement even in traditional buildings, but we can reinforce it in sustainable project. And there are some other activities that we could really do better job with. And you will see that I have several references coming from Dr. Kibert, Charles Kibert, that is one of the leaders in construction, sustainable construction. So if you like to check it out, his latest book from last year, it includes in more detail some of these statements. But the first one, and I listed here different activities that could happen throughout the life of the construction project in the timeline order. So the first one is how we plan site protection. And I'm going to focus on that more throughout the lecture. This is just the summary. How we can reuse the materials on site rather than transporting them somewhere else. How do we buy material handle it on the site and store it on the site and then install it. And then how we can really reduce pollution that construction activities generate, not only on the actual construction site, but also on the surrounding environment, if it's in a dense urban environment, to the surrounding neighborhoods and commercial buildings. The big issue is indoor air quality, and I will call it indoor environmental quality too during the construction phase. And then what Emilia asked me to focus more on, and we're going to touch on that several times throughout the lecture, is how we handle the waste. During the demolition, if we are demolishing the building on a site and building another building, and then also during the new construction project. And then the last one, which is really getting more momentum here in the States by the construction companies, they do monitor how much energy and water they use during actual construction on the construction site. So these are some major activities in general that could be done differently on a sustainable project. So moving to the rating systems, if you can raise your hand, how many of you heard of LEED? I can see the classroom, so that's good. One or two, three. Okay, and then the Living Building Challenge. I just want to see how much I should cover, kind of, and then Envision. And I apologize, they're all US based except for LEED. LEED is internationally known, and actually in my sustainability class I showed last year example of the building. It's a residential project in Brazil that got award for the LEED project. I didn't put it in this presentation because it's out of scope, but I know that it's implemented in Brazil too. So all these rating systems are basically like checklists that you go through. They're all sustainable approaches, either in design, construction, or operation of the project. And I'm talking about project, it could be a building, it could be infrastructure. And then you go through this checklist, and depending on how many criteria your project meets, you will earn certain number of points, and when you add these points, you fall into certain category and you get certification for the building. And please, if you have any questions, just stop me, interrupt me, jump in. And I'll give you some examples here of LEED in a moment. But when I compare these three different rating systems, they all talk about erosion control that we normally do on the site. Then we talk about using materials that are locally available. So we don't transport them from 1,000 miles away and have big transportation impact in terms of CO2 emissions on the environment, plus the cost. They all talk about construction waste management. They're talking about deconstruction. They're talking about preventing pollution, providing good indoor air quality for construction workers, and then commissioning of the systems. So here on the right side, I have a really nice example of a project that was completely deconstructed, and they organized materials nicely by the type of the material, and this material could be reused on maybe the same project or maybe on another project that is close by. So the goal is really to demolish the building or deconstruct to the extent that material could be reused rather than taken to the landfill. Here on this bottom picture, we have example of a worker commissioning systems. Are you familiar with the term commissioning? If not, I can explain. If you want me to explain, maybe raise your hand. You are familiar? No? No, not familiar. Okay. I'll mention briefly why is commissioning important and some flaws of the rating systems, including LEED. LEED originally was focusing only on design. So we have a design team, including architect and mechanical engineer. They will design the mechanical system, and they can run simulations in the software, and software will give us the output and say, this building will perform great. It's going to be low energy consumption. We're going to have good ventilation of the building. However, some of these software are not really always accurate. and it can misguide the designer. So what we need to do during the construction phase, before we install the mechanical systems like air conditioning system, we want to make sure that system is working properly. That will be commissioning. Once it's installed, we also want to run the system to ensure it works properly. And this commissioning could happen during the construction phase, but also during operation of the building, because sometimes you have some flaws in the mechanical systems that you may not notice unless you look at your energy bill and you suddenly notice, oh, it's much larger, so maybe mechanical system needs to be calibrated again. So commissioning is basically inspecting and testing of the systems. Is there a question in the back? No? Question? Emilia, if you can
É por causa do microfone, mas já...
unmute if there is a question.
Pronto. Tem que ser o teu, né? Vai. Posso? Pode.
I have a question. It's probably an easy question, but I just don't know. I've never heard about rating systems, so I don't know if that's an international concept or
I apologize. I'm just hearing echo. I don't know if a student can come closer, or Emilia maybe repeat the question. I don't know if that will work.
Turn off a little bit your mic.
Oh, my mic.
Yeah.
Okay, I can mute.
Okay, thanks.
Okay, thank you. It's probably an easy question, but I've never heard about rating systems.
I am sorry, I didn't hear the question. Emilia? I don't hear anybody now, or I don't see anybody. Yeah.
Is it okay now?
Okay, now I can see you. Yes, great.
Okay, so it's an easy question, but I've never heard about rating systems. So is it an international concept, or each country has its own rating?
Are you asking about quality of the mechanical systems, if it's rated, or about rating systems?
No, it's about the rating. Like, I suppose there are like a few rules that the construction has to match. Every country has its own rules, or it's like an international thing.
There are international ones, like for example, BREEAM. It was created in England, but many countries use. AQUA, which is HQE, is from France, but many countries are using. Brazil adapted and called AQUA. LEED was created in the United States, but is universally applicable. And if any country wants to have the LEED certified, they have to go through the LEED from the United States to certify the thing. But each country also created their own ratings. Like Brazil has Selo Procel, Selo Caixa Azul, Selo B. They have many. Each country also adapts to their thing, but there are some international ones. Is that correct, Svetlana?
This is correct. What is happening with LEED is gaining momentum around the world. It originated in the United States, and Emilia is right, like Brazil has their own, Germany has their own, what else? Is it possible to mute? I'm sorry. Mute me on this level, yeah. It's just an echo. So, yeah, Emilia is right, and it's a great question. If you want to go with LEED, for example, in Brazil, you will need to prepare the certification documentation by yourself, but then you need to go through USGBC, which is United States Green Building Council, that is third party, and they verify your project. So we cannot say, oh, I think it's LEED project, and they will just give it to us. You need to go through their process. And there is Green Globes that originated in Canada. Singapore has their own. So yeah, Emilia is correct. There are so many different rating systems, and there is no one universal. But LEED is kind of the most popular here in the States. And I do agree that I will not show today in the presentation because it's again different lecture. but the buildings here in the States that are high performing really didn't aim to go for LEED or Living Building Challenge. They just wanted to do the right thing. And then eventually, because they did design and construct great buildings, they got both LEED and Living Building Challenge. And some of them WELL. WELL is another rating system that we use here that focuses on building occupants. In terms of performance of mechanical systems and energy consumption, we follow at minimum International Energy Building Code, but it's not mandatory. Like, it's really interesting that it's based on the city and the county, and we could adopt it or change it. But in general, yeah, we go by that International Energy Code, which is not as stringent, and I would say as LEED and Living Building Challenge. And this is a whole nother topic. I'm sorry, I'm introducing another topic within this topic, but it's a good question about LEED. We did have in past LEED buildings not performing well and lawsuits. So commissioning is really important to make sure that building really performs as it is designed for the owner. Any questions, or I should move on? Can move on? Okay. So this is example of LEED. Without going into the details, you can see that there are so many different criteria that could be met. If you go for LEED, you go through this checklist, and then I highlighted some criteria that has to be met or could be met if you're looking at the sustainable construction. So, like I mentioned earlier, you need to, if you want to really get LEED, you make sure that you are preventing pollution. This is in this category on the sites here. Then you're doing basic commissioning, and that you plan to really manage your waste. If you just have a plan and you don't implement it, you're still fine. But if you want to earn some points, then you really need to implement that management plan. And in general, I think, what's the point of the plan if we don't implement it, regardless of LEED? And then again here, if you want to do more commissioning, you earn some points. And like I mentioned earlier, you go through this checklist, you add the points that you meet, and then based on number of total points, you will earn your certification. And I think I cut here platinum, but this building, for example, got platinum rating. This is example of the school project in Wisconsin that is very cold at the moment, so it has very harsh winters. And I picked the school project because in general, schools in the United States are really concerned about well-being of the students, and they aim to go for LEED buildings. And here on our campus, we have minimum requirement for every new building constructed to be gold LEED, which is the second rating going from the top. And I picked this example because if you look at this project and just focus on construction-related criteria, they earn all the points. They did enhance commissioning, they managed the waste during the construction, and they provided good indoor air quality for construction workers during the construction. So this project was a platinum version for schools. LEED has several different LEEDs. It's not only one universal LEED. So we have for commercial buildings, residential buildings, school projects. So it's really very sophisticated in terms of types of the project that it covers. Any questions about LEED before I go to LBC? No, okay. Living Building Challenge is relatively new compared to LEED. It's been around maybe for more than 15 years now, and LEED is in its 25th year, I believe. And it's pretty challenging. It's Living Building Challenge, but it's a challenging rating system because it has 20 criteria, and you have to meet them all if you want to get your building certified. And in this presentation, I'll just focus on construction practices again. So, for example, we use a lot of wood in residential construction and some smaller commercial projects. So requirement is that half of all the wood products used in the project, so it could be structure, it could be doors and windows, must be certified by Forest Stewardship Council, which means that wood that we are using on the project cannot be cut from Colorado forests where we go for hiking. It needs to be sustainable managed forest that has purpose to produce construction materials. So that's about half of the products, or it could be salvaged. Are you familiar with salvaging as a term? Do I need to explain? If you raise your hand, I will understand. I should explain maybe. Yes, okay. So, for example, at the end of the life of the building, if it's demolished or deconstructed, we want to be able to salvage that material and then reuse it on another project. And here in Fort Collins, where we are located, we have a store where you can go and buy salvage material and reuse it for another project. For material harvested on site, I have this example from Costa Rica where we took students for study abroad, where people grow bamboo on their site and then they cut it and they use it for building a house, for example. So it's really very local. Do you have any examples like this from Brazil? That you use materials that are harvested on the site or salvaged? If you want to share. Would you like to share? Yeah, I'll mute myself, and if you want to unmute.
Marcia said that here, what they have for construction is foresting. Like, for example, if you're taking an area, you have forest, part of the Atlantic forest. But it's not reused. It's something very new I never saw, like in the site, plant, okay, used in the construction of the city. Is that correct? What you said for the harvest on site, yeah? We don't have that here. That's really interesting. Yeah.
I need to unmute. The point is to minimize that transportation, right? Because it's time and cost and then CO2 emissions, so that's the problem. When I lived in Serbia, everything is local, right? Like we build from brick a lot, and brick is manufactured within 25 kilometers, right? So it's never far. And we didn't have that luxury of importing materials from other countries because it's very expensive. So out of necessity, we use local materials. So going back to Living Building Challenge, they want all materials, and they kind of broke it in 4 equal categories in terms of amount of materials coming from different regions. But 1/4 of materials will come within 500 kilometers. And I know in the United States, 500 kilometers is not a lot because we are a big country, and maybe it's similar in Brazil. But in Serbia, that's entire country, right? So it needs to come from very close proximity. And then another 30%, 1,000 kilometers, and then 5,000 kilometers. So if you want to import something overseas, it's not really sustainable, but that could be within this 25% of materials. And we do have buildings. We have Living Building Challenge building that was first certified in Seattle, and they imported their windows from abroad. But they justified that because it's a triple glazed, very energy efficient window that could fall in this 25%. So there is a little bit of flexibility. Another category that Living Building Challenge looks at is net positive waste. So for example, if we don't have any waste during the construction, that will be zero waste. But if I'm reusing some materials, like we talk about salvaging materials, then I'm having this net positive waste. Like I'm now reusing previous material, I'm not using raw materials anymore. So that takes me to that category of net positive waste. And the requirement of Living Building Challenge is to have one salvage material per 500 square meters. So that would be most likely commercial building, I would think, in Brazil and here in the States. So for every 500 square meters, one salvage material, which I think it's not hard to achieve. It's possible, right? Another requirement for this rating system is that we want to collect this waste material. So again, going back to waste, going back to reusing or recycling. So there needs to be a plan. And then they want us to divert about 80% of all construction waste from the landfill. So now we need to be creative and think how we can use this waste for something else. If it's maybe concrete, or here we have some different kind of materials that they're looking at. So soil, you can really divert 100%. So if I'm excavating and I need to backfill, after a project is completed, I can reuse the same soil. If I have extra soil, I can take it to another site. So the idea is that it stays locally and it's reused. Metals are difficult to really reuse 100%. So if we can recycle steel and aluminum, that's great. And then for any demolition, it's really hard to divert everything. So 20% could be taken to the landfill still. So they allow for that amount of waste to be taken to the landfill. And we're going to look at waste in a little more, but these are some requirements for Living Building Challenge. Any questions about this rating system? It's pretty stringent, but I feel it's better than LEED because it looks at the building life cycle. And basically, you need to operate building for 1 year before you can apply for certification to ensure that it's really operating as it is designed. So it's a really, I would say it's a good rating system to follow. And now envision, for those of you that are interested in infrastructure projects, this would be, for example, a road or highway or bridge or airport or park. So there are all sorts of projects that will belong to infrastructure. They are looking very similar to previous two rating systems, to improving construction workers' safety, to minimizing impact of construction on the surrounding environment. So that's a quality of life. And then when it comes to materials, again, it's about recycling and reducing waste. And this is interesting for energy and water. We want to minimize the use of energy on the construction site and then use of water. How it's in Brazil, here in United States, we use potable water for concrete mixing. We need clean water, which is fine for concrete, but it's potable water. So it's a huge problem. Is it same in Brazil? Or I think we have somebody who is working on concrete, one of the students. No?
You're on mute.
I need to unmute myself. I used to teach about bigger sustainability class, more broader and comprehensive, when we talk about quality of water and scarcity of water. And I know there is problem with water availability for people, right? In Brazil and Africa and Asia, here in the States, we are spoiled because we have potable water all the time that is good quality, but we use the same water for concrete, unfortunately. So it's a huge problem. Anyways, this is just brief intro to rating systems and how they consider construction activities. And now we are ready to move to more specific topics and how we can do things differently during construction phase. And I was thinking of focusing only on these 5 major topics. since there are many others, but then we have limited time and maybe to go a little more in depth. So how we protect the site, how we handle materials, indoor air quality, waste, and then I would like to talk about construction equipment at the end. So these are some topics that we can look at. So if I assume that you heard about controlling erosion, is that right, on the site? It's a civil engineering program, right? Let me mute.
Here it's a very big problem. We have some hills, and the problem is that the hill population has been constructing these hills kind of around the city. And when it rains, we have I don't want to say, but slides, earth slides, and people get killed. So they try to put plastic to avoid that the water will filtrate and carry the earth, but we have this problem here in the city.
So this is a good example, right? Because it is a problem in general. It doesn't relate only to sustainability projects. We do have class here in construction management where we teach our students how to control erosion and sedimentation. And it's even more important during the construction of sustainable building. What I wanted to point out, typically we use plastic-based materials, but thinking about more natural approaches to erosion control, this is example of the jute that you could use that is more natural in material, like we call it primary material, because it doesn't take much energy to be produced like plastic, super important for sustainability. And also, some of my students presented on coconuts. I don't know if you heard of them, if it's available in Brazil, based on coconut, right? So they use coconut to make these more, I would say, environmentally friendly cloths. So something to consider. I don't know what is the extent of erosion control that you need to provide and whether these systems will work, but something to think about. We do have problem with slides here too. We had huge problem in Texas with the neighborhood that collapsed. So I think it's probably common around the world. Any questions or comments? I like it to make if I was in the classroom, I would be talking more with you than we are in online. Any questions or comments? No? Okay. Another important approach is about reducing site disturbance. So here in the United States, we have a law that protects endangered and threatened animal and plant species. And in Colorado, we have bald eagle. And I'm sure in Brazil you have even more variety in animals and plants that need to be protected. And I don't know if there is a similar kind of law that you need to follow. Do you have it or no? Do you know?
Yes, there is.
We do have. Olbina, can we?
Não, ela tá falando sem o microfone dela tá ligado. Aqui tá funcionando. Aqui tá normal.
Yes, we do have Svetlana a law that protects.
Pode ligar.
Okay, yeah. So for example, if we had a project here close to Fort Collins, it was infrastructure project, and there was an eagle nest, and they need to relocate it. They couldn't get permit to move on with the project unless they protected that eagle nest. So it's pretty common here, and it's part of permitting process. Another one is about on-site parking. So I had a colleague and a friend who built a sustainable passive home here in Fort Collins. And I took my class to the site, and he requested that we don't park on the site. We need to park off his site in order to really reduce disturbance of the soil on the site. So I don't know how it's in Brazil. When I lived in Serbia, I never drove a car, right? Like I live in the city where we had mass transportation. So we really minimized driving of individual cars, but here in the States, everybody drives their own car. So now we have all these cars coming to the construction site, and that disturbs the soil. So we need to make sure that we are maybe carpooling, not parking on the construction site, and have even traffic-free areas on the site to avoid that disturbance of the soil. Another interesting example from that same project where I mentioned Eagle, because it was infrastructure project, we had to relocate the road that was flooded, and it is in the kind of in the mountains. So they staged all the equipment and the materials completely off-site at the beginning of the site, but it was not on the actual site. So that's another option. Sometimes we have projects that are in very dense urban environments. So it's in downtown. There are a lot of buildings. Site is very small. So there is no space for actually equipment, and there is no space for materials. So we need to just bring equipment and material as needed, as then is installed. So that will be another way to protect the site. And then, I don't know if you experienced that, but I did live across a couple of construction sites, and there is a lot of dust and there is a lot of noise. So not only that affects construction workers, but it affects surrounding neighborhoods. So it's important that construction companies, things changed a little bit, especially with this BIM and virtual environment. It is possible to have a conference call instead of being on site, right? So that's another strategy. It saves time, no driving, no pollution. So if it's possible to do a conference call, that could be a viable solution. I do like everything in person still, and I wish I'm in Brazil, but imagine how long it will take me to get to Brazil and give a lecture that is a couple of hours or 1 hour and a half and then go back. So it's really convenience. Carpooling, I already mentioned. Here in the States, people are leaning towards electric vehicles, but they're still expensive for us, even for us, right? So it's not that affordable like a gas-based car, but that's the goal for future, that we're using more electric and hybrid vehicles rather than fuel-based. And I will show at the end a few slides on electrical construction equipment. And then we already spoke about recycling and reusing fencing. For example, here on the right side, you can see this picture of the fence that shows the boundary of the site, limits the boundary, and that could be easily disassembled and assembled, versus the one that you built on site, demolish, and take material to the landfill. So it is really important to think about reuse of fencing too. I found this really interesting software. I haven't tested it yet, and I'm not sure if it's free, but it will be interesting to try it maybe in the class, because it's developed by Building Research Establishment in the United Kingdom. And this organization is really famous for developing and administering BREEAM, which is another rating system. It's actually the first rating system in the world for sustainable buildings, before even LEED. So they developed this software that helps companies track and monitor their energy use, trying to use my mouse, energy use and water use and amount of waste and use of materials and type of materials that use on the building, and then transportation impact. So it's pretty powerful because it's systematic. And we do have a company here in Colorado that is really on the cutting edge when it comes to sustainable construction. They do monitor their impacts. They do measure in numbers, like how many CO2 emissions were happening on this project due to transportation or due to use of electrical equipment or regular equipment. So they're really very considerate about their sustainable practices. So again, maybe something to check, because it's a nice piece of software that could be used by construction companies. When it comes to material procurement or buying material and delivering to the site, again, goal is to minimize transportation, and in this case, to minimize packaging. So often materials are packaged, we remove packaging, and then we throw it to the landfill. So it's another waste, right? So if you look at this slide, this is a company that does use heavy machinery to fill these big bags, let's say with aggregate for concrete, maybe this is gravel, and once it's packed, they can put it either on the truck, or I think in the next slide, I have a big example of the big crane that will lift these big bags and maybe put it on the train. We transport here with the train too, a lot. So eventually you bring it to the site, you use the material, and these bags are going back to the manufacturer that could be reused for the next cycle. It's a very simple strategy, but very useful, and it minimizes waste too. So less waste because we are planning better material use on the site. I mentioned earlier that usually in the very dense urban environment where sites are small and there is no space around the site even to park the truck, we may need to do just-in-time delivery. And just-in-time delivery means if I'm installing today a gypsum board for my walls or maybe ceiling, I'm going to deliver it this morning and then start installing it today. There are a couple of benefits. One is like storing, right? Like I don't need to store it on the site. I don't have much space. The second one is I don't need to cover it. What is the problem with gypsum when it comes to the moisture? Any idea? Maybe I'll stop here and ask the class. Gypsum as a material and moisture, how that works.
Tem até em João Pessoa um teste criando casas da Universidade da Paraíba. E como tem muita perda de casa, por causa das catástrofes e tal, eles estão fazendo um protótipo de casa que é feita de gesso, já que aqui a gente tem uma matriz muito grande, assim, de produção. Só que aí o gesso não entra em contato exatamente com o solo, ele tem tipo uma base assim, meio de concreto, mas a estrutura mesmo é de gesso.
They're saying that the gypsum is a little bit sensitive to water. Sometimes you have a variation of gypsum that accepts water, but and they've been using it too. But I think maybe that's one of the elements.
Great, that's exactly what I was looking for. So there are, like, yeah, I agree, there are gypsum boards that are more resistant to water because we add certain additives. But in general, traditional gypsum board absorbs moisture. So that's a huge problem. And we don't want that to happen during the construction phase. If I'm storing it on the site and I don't protect it, it may absorb the moisture and then it's useless. And we have to throw it away, or we're going to have mold in the building. So that's why it's really good to think about just-in-time delivery, because then I don't need to cover it and I avoid this kind of problems. Any plastic-based materials will be exposed to sun maybe, then we have UV radiation damage and they're again useless. So we need to discard them and bring new material. If material site is not well organized, and there's equipment moving around and people moving around, there is a chance that this material will get crushed or punctured or damaged, so we cannot use it again. So there are all these different little things that we can take care of to be more efficient with the material. Moving to the indoor air quality, I like the indoor air quality term. It focuses on air, but I like even more a term called indoor environmental quality. And environment or environmental quality includes more than just air. So if you think about construction worker here on the right side, he's wearing earplugs to protect him from noise. He's wearing this mask to protect him from dust and any chemicals, right? We may have some vibrations in the building due to equipment working in some areas. So that can be also having negative impact on the worker health. So it is really important to protect our workers. That's part of social sustainability. When we teach our students sustainability here in States, we talk about environment and economic sustainability and social sustainability, and they're all very passionate about environment. But when it comes to economy, fair trade, affordability, equal opportunities to everybody, and then social sustainability like our health, they're not there yet. So it's my job to really encourage them to think about these topics. So one is worker health, right? So again, we need to make sure that they're not exposed to VOC. Are you familiar with VOC term? VOC, volatile organic compounds. And I don't know if it's the same term when you translate it to Portuguese, it may be different, but this will be, for example, off-gassing from carpet, right? If carpets are not green or sustainable, like green, not green color, but not environmentally friendly, I had that experience in our building where we installed new carpet and it was off-gassing so much for a few days that we couldn't breathe. I had to close my office door and then open my window all the time to ventilate that space. So construction workers could be exposed to this kind of chemicals that are toxic basically for their health, especially for the lungs. If we have demolition of the buildings, here buildings that are built in 70s have a lot of asbestos. And if we need to remove this asbestos, we need to hire specialized contractor that knows and is certified how to work with asbestos, and they have full body protection not to be exposed to asbestos that is known to cause cancer. So something to think about during the construction phase, how we protect our worker health, in addition to other safety measures that are like harnesses for the working at heights and all sorts of other personal protective equipment. So the major solution would be to use low emissivity materials that don't release any toxic contaminants. Ventilate the spaces, right? So if we have a building that already has a shell envelope, like windows and doors and a roof, and we are working with some materials that are off-gassing, we make sure that we open these spaces, especially during the night, if it's not raining or snowing or something like that, to provide fresh air so people are not exposed to these toxic contaminants. And then using personal protective equipment like we saw in this picture here. It is really important to clean the job site. When I worked in Serbia, our sites were not super clean. We went to Germany, we did study abroad, and their sites are like pharmacies, I say. They're super clean. So cleaning job site is really important to protect, again, people from any exposure to toxic contaminants. Another one is how we schedule construction activities. So wet activities should happen before dry activities. So if I am, for example, finishing my interior wall made of brick, for example, with plaster, this is considered wet activity. So I'm putting plaster first, and then I'm installing carpet. That is considered dried activity. So I'm not introducing any moisture into the carpet if I was installing maybe my plaster after I installed the carpet. So it's really important to think about going with wet or moisture-based activities before any dry activities to protect the materials and to protect workers inside. And then mechanical systems, we called it HVAC, heating, ventilation, air conditioning. Here is an example of the construction company that when they bring mechanical equipment components to the site, they cover it with plastics completely. Any idea why they do that? I'll unmute my... Why do we want to cover mechanical components with the plastic?
Turn the HVAC on, they would open the room.
Does it have to do with temperature? Not the heat or?
It's really about indoor air quality. We want to make sure that no dust from other activities go inside the ducts, right? And on the right side, you see it's already installed in the ceiling, and it's again covered again for the same reason, because if anything enters the ducts and we start running the system, it could be a dust, it could be mold, so we want to prevent that. For the temperature, I would say maintaining temperature of the, or maintaining temperature once building is completed and mechanical systems work will be part of commissioning. I agree. There's another thought I'm just having. It could be different in hot, humid climate. It could be different in cold climate. Like yesterday, we had -7 Celsius. So if I have any water, it's going to start freezing. So it damages it. If I'm in Florida and maybe in Brazil, if it's hot and humid, now we have too much humidity. We need to make sure that that moisture is not entering the ducts during the construction. So there are a lot of things going on that we need to think of to ensure good indoor air quality during construction and when building is occupied. Moving to waste. So this is not very encouraging slide. And this is for students that are doing masters and PhD and maybe undergrad research. And I always explain that in my class. If you look at this data, it's from 2018. And I just went to Environmental Protection Agency website where they publish this information. And as you know, when we do surveys or any kind of research, we survey industry for about 1 year. And then we collect the responses, we analyze responses, we write report. That takes another year. So when we get the data published, it's like already 2 years old, right? So probably during the COVID, they didn't do much. But what's discouraging when you look at this United States, we had from just construction 136 millions of tons of waste in '96. So that's about more than 25 years ago, a little more. And in about 20 years, this amount went up 4 times. So we're producing 4 times more waste in construction than we used to 20 years ago. Also, what's happening in construction, when we compare construction to other industry sectors, we are one of the largest contributors to the waste in the United States. So how we can fix that? If you look at a type of waste, large majority comes from concrete, either asphalt-based or regular concrete, and this is more than 85%. So any idea what we could do about that? I do have some suggestion, but maybe because I think one of the students is doing research in concrete, what could we do with this concrete that is waste?
Maybe we can grind it and reuse it as an aggregate.
That's what we teach our students here, right? And that's what we're trying to do. We can use it as an aggregate, so reuse, right? So imagine now 80% that goes to landfill goes back to concrete, And we are not using raw aggregate. We don't need to now go and get gravel and rocks and sand from somewhere else. So that's a great solution. We can reuse brick and clay. We can recycle steel. And then think about reusing these asphalt-based materials or gypsum-based materials again. So how we can recycle at least, if not reuse. Some problems that we have here in the States, we like to build big, right? So our houses are huge, which is not necessary. I grew up in small house with my parents and sister, and it was 100 square meters. In Serbia, that's huge house. In the United States, it's small house. So it's all this cultural thing, right? Like what is considered normal. So I teach my students, we need to build smaller homes because we don't need this big home. Why do we need like 200 square meters when we can live in maybe much smaller? So when we decrease size of the building, we decrease material use. Also, what I put here as an example, when I work for the curtain wall company, I would need to design the curtain wall and then take the quantities off and order the material for these aluminum profiles. And whatever I estimate we need for a project, we are adding 10% to that for waste. Can we be more precise and reduce that waste factor? Can it be 5% or less? So that's the goal, to minimize these waste factors. In the States again, and it was different back in Serbia, we have one general contractor that usually maybe subcontracts concrete, and sometimes they do their own concrete, but in general, they're just managers. And what they will do, they will subcontract different scope of work or different type of work to subcontractors. So we have subcontractor for steel and concrete and masonry, which will be brick in this case here on the right side, and subcontractor for doors and windows. So these subcontractors are actually responsible for managing waste of their own products and materials. So that's something to coordinate as a general contractor, coordinate subcontractors. And yes, no?
Yes, please.
So value engineering is, for example, concept where I'm comparing two different materials that could be used for a building. So for example, if this is a commercial project, it's not, it's residential, but imagine this is a commercial project and I could have facade made of brick, or I could have a curtain wall made of aluminum and glass. And brick is considered more environmentally friendly material. It requires less energy to be produced, and it makes less impact on the environment over the life of the building. So value engineering is basically comparison of two different materials to figure out which one has lower energy consumption for production, will provide better energy performance of the building, will have fewer CO2 emissions during manufacturing, disassembling of the building. And then at the end, when we focus just on waste, I'm thinking, can I maybe reuse this brick for another project? Or can I recycle this aluminum? What is more feasible when it comes to waste? So brick is probably a winner, right? And we are always talking about end of building life. Really, in sustainability, we want buildings that last a long time. So I'm sure in Brazil you have buildings that last for 1,000 years, like we have in Serbia, some monasteries that have been around for a very long time. But in the United States, we build the buildings to last for 50, 100 years, and then we're going to demolish and build new. So we need to change that mindset here to make sure we are building very, very durable, long-lasting buildings. And then we already spoke about reusing and recycling materials. Emilia, how we are standing with time? Because we're a little bit late. Do we have 2 hours or we have 1 hour and a half?
We have until 5 o'clock, 5:10.
I can go with the VTR. Okay, I like to show this video. Yeah, maybe we have 20 minutes or so, but let me show you this video. It is pretty interesting because this gentleman is a home builder and he will show some examples of salvage materials that he uses. It's fun to watch. I'll show you only 5 minutes, but if you have time to watch it later on, he goes into all philosophical discussion about our bad consumption patterns and how we should change. So it's really focusing more on that philosophical side of sustainability later on. But maybe for today, we just watch 5 minutes. And I will need to reshare, and if you don't hear me, just shout at me and say we don't see it or we don't hear it. So I did practice this to make sure it's working. And I need to enable the sound here. Oh, no, I don't think I did it well. Let me try again. Can you see this gentleman? If you can raise your hand if you see it. Okay, and I'll start the sound. You hear it? Okay.
Thank you very much. I have a few pictures, and I'll talk a little bit about how I'm able to do what I do. All these houses are built from between 70 and 80% recycled material, stuff that was headed to the mulcher, the landfill, the burn pile. It was all just gone. This is the first house I built. This double front door here with the 3-light transom that was headed to the landfill. Have a little turret there. And then these buttons on the corbels here, right there, those are hickory nuts. And these buttons there, those are chicken eggs. And of course, first you have breakfast, and then you fill the shell full of Bondo and paint it and nail it up, and you have an architectural button in just a fraction of the time. Then this is a look at the inside. You can see the 3-light transom there with the eyebrow windows, certainly an architectural antique. Headed to the landfill. Even the lock set is probably worth $200. Everything in the kitchen was salvaged. There's a 1952 O'Keefe Merritt stove, if you like to cook. Cool stove. This is going up into the turret. I got that staircase for $20, including delivery to my lot. Then looking up in the turret, you see there are bulges and pokes and sags and so forth. Well, if that ruins your life, well, then you shouldn't live there. This is a laundry chute, and this right here is a shoe last. And those are those cast iron things you see at antique shops. So I had one of those, so I made some low-tech gadgetry there, where you just stomp on the shoe last, and then the door flies open, you throw your laundry down. And then if you're smart enough, it goes into a basket on top of the washer. If not, it goes into the toilet. This is a bathtub I made out of scrap 2x4 here. Started with a rim there, and then glued and nailed it up into a flat, corbelled it up, and flipped it over, and then did the 2 profiles on this side. It's a 2-person tub. After all, it's not just a question of hygiene, but there's a possibility of recreation as well. Then this faucet here is just a piece of Osage orange. It looks a little phallic. But after all, it's a bathroom. Then this is a house based on a Budweiser can. It doesn't look like a can of beer, but the design takeoffs are absolutely unmistakable. The barley hops design worked up into the eaves. Then the dental work comes directly off the can. It's red, white, blue, and silver. Then these corbels going down underneath the eaves are that little design that comes off the can. I just put a can on a cop here and kept enlarging it until I got the size I want. Then on the can it says, this is the famous Budweiser beer, we know of no other beer, blah, 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 blah. So we changed that and put, this is the famous Budweiser house. We don't know of any other house, and so forth and so on. Then this is a deadbolt. It's a fence from a 1930 Shaper, which is a very angry woodworking machine. And they gave me the fence, but they didn't give me the Shaper, so we made a deadbolt out of it. That'll keep bull elephants out, I promise. And sure enough, we've had no problems with bull elephants. The shower is intended to simulate a glass of beer. You've got bubbles going up there and then suds at the top with lumpy tiles. Where do you get lumpy tiles? Well, of course you don't. But I get a lot of toilets, and so you just dispatch a toilet with a hammer, and then you have lumpy tiles. And then the faucet there is a beer tap. This panel of glass is the same panel of glass that occurs in every middle-class front door in America. We're getting tired of it. It's kind of cliched now. So if you put it in the front door, your design fails. So don't put it in the front door. Put it somewhere else. It's a pretty panel of glass. But then if you put it in the front door, people say, oh, you're trying to be like those guys, and you didn't make it. So don't put it there. Then another bathroom upstairs. This light up here is the same light that occurs in every middle-class foyer in America. Don't put it in the foyer. Put it in the shower or in the closet, but not in the foyer. Then somebody gave me a bidet, so it got a bidet. This little house here, those branches there are made out of Bois d'Arc or Osage orange. And these pictures will keep scrolling as I talk a little bit. In order to do what I do, you have to understand what causes waste in the building industry. Our housing has become a commodity, and I'll talk a little bit about that. But the first cause of waste is probably even buried in our DNA. Human beings have a need for maintaining consistency.
So I would stop here because now it's becoming more like a philosophical discussion. But I just want to show this first few minutes because it's a nice example of how he found different materials that will be otherwise take to the landfill. It will be waste, and he reused it for the house project. So just as an idea. Let me go back to my slides. Are there any comments or questions? No? Yes? No, okay. What's interesting, when it comes to waste, we can recycle about 75%. 3/4 of all materials we already mentioned, like wood and concrete and masonry, let's say brick and aluminum and steel and gypsum board. So major materials that we use typically for the buildings are recyclable. We can also prefabricate. I'll show you some prefabrication examples. We talk about buying materials in huge quantities and big packaging in bulk, which also helps with minimizing the waste. And then deconstructing building rather than just demolishing and reusing that material. So I will have one example, a short video on that. And then recycling as much as possible demolished material that cannot be directly reused. So I'm not sure, do you see this kind of dumpsters on Brazilian job sites? You do? Great. Oh, that's a great job. Yeah. So separate materials, right, for recycling. And this is example of the company from United States that got this green certified contractor status. So we have Association of All General Contractors. It's a big organization. It's called AGC acronym here in the States. And contractors can take exam and become green certified contractors. So it's different than LEED. LEED is more like for designers and contractors, but this is really focused on general contractors. And on one of their projects, they had this board on which they showed that they're reusing and recycling asphalt and brick and the concrete and drywall and metal and wood and normal ones like paper and cans and bottles that are happening on the site anyways. So they recycled about 80% of the materials or reused, which is very close to what living building challenge expects if you go for that accreditation, almost 1,000 tons. So they're really focused on green construction. And this is their example, like how they have these dumpsters that separate waste by the type. This video is coming from Environmental Protection Agency, and it should run here without the problem. I was able to embed it. So only a couple of minutes about deconstruction. And normally in this country, in the United States, we don't deconstruct, we demolish. I've seen this in Florida, they demolish hotel, all that waste goes to the landfill, and then they build another hotel at the same site. So I don't understand why is that happening, but that's how it's going sometimes. So deconstruction is the idea of, if I build this from steel or wood, I can create connections that could be disassembled at the end of the building life, and then we can reuse that material again for another project. So I'm gonna run this, and if you don't hear me, just please raise your hand. And only a couple of minutes, not to take much of the time. Here.
Environmental footprint. In 2018, construction and demolition activities in the United States generated 600 million tons of material. Discarded materials present significant opportunities for reuse.
Deconstruction is the intentional dismantling of buildings to ensure that you're preserving as much of the material as possible for reuse, repurposing, or recycling.
Deconstruction and salvaging materials is not limited to commercial construction and demolition companies. Property owners can also take part in deconstruction and salvaging materials.
Consumers can participate in deconstruction by encouraging their contractors to salvage materials instead of discarding them.
Many communities now have access to companies and organizations that specialize in deconstruction. There may be a store near you that accepts and resells donated surplus and salvaged building materials.
Deconstruction materials can range from architectural salvage like doors, windows, trim work, and molding, to items that are removed during home improvement projects and upgrades, like cabinets and other easily removed fixtures.
One way EPA promotes deconstruction efforts in the local community is to provide grants to organizations involved in deconstruction and recycling and reusing old building materials. Deconstruction provides a range of benefits for communities.
Reducing the amount of material going into landfills and improving the environment, but there are also opportunities for micro enterprises, for businesses to be created, for historic preservation, and there's opportunity for workforce development.
Significant economic benefits can be gained through deconstruction because community residents and small businesses can access those materials for a fraction of the cost to buy new materials.
Whether you are taking on a large construction project or are looking for a few materials, consider deconstruction and using salvage materials. It will not only help your bottom line, it will also benefit the environment and your community.
So I thought this would be, oops, I think I need to move to the next slide. Any comments or questions? Do you have stores like this in Brazil where you can get salvage material? No? Yeah. Do you reuse materials like this? Do you know?
There are some people who do the construction that they go and buy specifically from some places, but it's not a practice where you have a store that has been collecting all this. In one place there is wood, one place there is, but you have to go after it, and maybe it was just received, once if you're, looking for it, you might be able to catch it. I think for cars, there's more. For houses and materials, there's a
sometimes the labor
sometimes the labor takes it home to construct their own houses without veterans,
To be honest, I don't think it's that widespread here, too. Habitat of Humanity that was shown in the video is an organization that has built homes especially for people that are in need. And then City of Portland, Oregon is very sustainability oriented, like they're very advanced. So it really depends on the community and culture and type of the project, but it's not widespread. But we're trying to educate our students that take these classes. They are now carrying over that idea to the industry, and hopefully industry will change. So it's not even here widespread. Prefabrications, benefits of prefabrication, it's in controlled environment, it's in the shop, workers are safer, not exposed to the rain or snow or cold weather, and quality of the product is much better, right? Because it's again very controlled and faster and less expensive. So precasting concrete instead of casting on place or prefabricating concrete is a simple strategy that could be used. We do use it mostly for commercial buildings and let's say garages and projects like that, but there is a bigger potential, right, to use precast concrete. Another idea is to use modular construction. Do you use modular construction in Brazil? No? Yes? So?
Like, for example, they have kind of container kind of things. Like, minha casa, minha amiga, eles tinham os containers que já vem com os holes, né? They have, but it's very rare.
Yeah, we have this stigma about modular construction, unfortunately, but they're high-end hotels in Florida built using prefabrication. So I think people need to change their mind. But anyways, this is a project, and again, there is a brief video, 1-minute video on this project that was built in Los Angeles for low-income and middle-income families. And there are 100 units, 100 apartments in this building that are all pre-constructed in the shop and just bought and installed on the site, right? And this project actually got platinum LEED. This is the highest rating for LEED. You can see, we'll see in the video some images of interior of the houses and then internal courtyard. But again, modular construction is probably way to go if we want to be sustainable economically and socially and then environmentally too. So I need to switch again to another browser to show you this video. I'm getting much better with navigating through Teams. Okay, do you see this house now? Do you see it? Yeah? There is just music, no, not other sound. So I thought this is a nice example again of pretty nice housing for low-income people that otherwise wouldn't be able to afford. And I would live in that home, like full of light and really nice interiors. And again, it's all modular. So something that we don't do normally, again, in this country, but I believe it's probably a future way to go. Another interesting concept, and again, I'm showing you some new stuff that is not done much in the United States at all, but companies are looking at that. So 3D printing, student that does concrete may be familiar that we can use concrete to 3D print the home. So this is big 3D printer, robotic machine that will be able to print, in this case, very rectangular straight shapes. But in general, it could be any shape, like concrete can really be used to achieve any geometry of the building. So this is example of the neighborhood in Tech. The same company built this high-end home that looks pretty nice. It has these circular concrete walls and then use timber for the roof structure. So again, beautiful building done with the 3D printing. And they found that 3D printing is beneficial for multiple ways. It will mean less waste, less time for construction, less labor cost. Here in the United States, we have fear of our workforce, of our construction workers, that they will lose their jobs if we go more into automation and robotics. But it is a matter of shifting how we train our workforce for different kind of tasks. So they're not going to be hammering anymore. They're going to be using robots. So it's different kind of and completely new approach that will be happening probably in the near future. Any questions about robotics, maybe? No. Yes. Yeah, well, I'm looking at the robotics and virtual reality training and augmented reality. So that's something that I've been working with a group of colleagues to really take it to the next stage or level. So time-wise, let me see how we are doing with time. We have only 10 minutes left, right, Emilia? Time flies. Do you want me to go over electrical equipment, or I wanted to hear from the class, from the students, maybe for the last 10 minutes, if they want to share any of their experiences or have any questions. For electrical equipment, we do have a lot of construction equipment going to be like electrical car, if you would imagine, and I can share that at the end. And they can run for about 8 hours on electrical, being charged on electrical power. So battery, let me just share that and then I'll stop there without showing any video or anything like that. So some examples are these excavators that have a battery, like car will have a battery, and you can use it for 8 hours on that single charge. So we're talking about excavators, or we are talking about this rope shovel, or this big compact wheel loader. So most of them will work up to 8 hours just being charged with the battery, similar to the cars. But I want to ask class and students if they have any experiences. Maybe if you had internship opportunity and you saw something that you feel was unsustainable or sustainable that you like to share. And any questions for me? Because we're close to end of class. And I'll mute myself.
Felipe works building hybrids.
Actually, one thing that we use a lot is we use the asphalt of the roadways. Sometimes when the road gets it's in the end of its lifetime, you have to rebuild it, and we take the asphalt out and use it as an aggregator. We mix it again and use it as a new product.
Yeah, great. This is a great example. Thank you.
She has a question. She has a question. Go ahead.
If you can come closer, that would be great. Then I can hear you.
So my question is, what are the most promising new developments in sustainable construction practices, and how can we stay up to date on them?
Can you please repeat just the first part? What are the most? I heard everything but the most important word, I think. What are the most
promising new developments in sustainable construction practices, and how can we stay up to date on them?
You know, I show you some fancy stuff like robotics, and our construction industry here in the United States doesn't buy into that yet. So there are some things that are not easily achievable. So I would say, yes, long term, let's work on that. But just simple practices like we saw today would be good way to start. If I say the most promising, probably robotics and prefabrication, because that's where we are going. We're trying to rethink how we can automate processes more because it's less expensive, less impact on the environment, safer for workers. If we can work 32-hour week instead of 80-hour week, that's a big accomplishment, right? Just for life, well-being of the people or construction workers. So that will be the most promising, but again, is the hardest one. And the simple ones, like we were seeing today, like just think about which materials we use, using more green materials that are less toxic for people and environment, and monitoring our energy consumption and water consumption. Simple things like that would be also a very good step forward. I mute myself. Can you hear me?
Another question is, yes. So I think most of our buildings are made of concrete, and I think one of the reasons is because the cost of labor is low compared to the materials price. So how do you think we could go through a transition from concrete to something less? Because less
CO2 and a lot of energy is used to just make concrete. But then on the other hand, if we think about building high density residential development, we do need to use concrete and steel or timber. In States, we have a lot of wood, so we use wood a lot because that's cheaper and labor is cheaper. In Serbia, we use brick a lot and concrete masonry units or clay masonry units. So if you have enough soil that you could use, for example, we could go more with brick or compressed brick that doesn't need to be baked. So that can be the major supporting structure for high-rise building. We still need to go with main structure to be made of columns and beams of concrete or steel, but then infill could be brick. So maybe one option, like going to these primary materials that are earth-based, that don't require much energy to manufacture. And they're very thermally efficient. Like concrete is good thermally too, because it's thermal mass, and when you insulate it, it's great. But I agree, we need to think about other materials. What is the height of the buildings in Brazil for residential, if it's like multi-family? What's the height?
We have many heights. If it's a lower income residential, generally see 4-story buildings. If you go to high level, for more expensive ones, then they become much taller, like 20, 30, 40 sometimes. So like if it's a lower income, it becomes shorter, a height is taller.
I've seen examples somewhere in Asia where they did like high rise, like 20 floors made of wood. So it is timber, it's a completely different engineering calculation and dynamics compared to concrete. But I guess we need to explore more and see how we could use this more natural, like if we can use timber, and we have pre-manufactured timber that uses like waste from the wood production too for the beams, for example, how we can use that and how tall we can go. Can we go with 20 floors? Yeah, concrete is good, and it's good and bad at the same time. Thank you for your questions. These are great questions. Anybody else?
So much. I don't think you have any questions. You look at the YouTube. And thank you so much. And it was so useful. It helps us, see what the top researchers are doing all over the world, and that it's something accessible to all of us. So that was it, Svetlana, my dear. Thank you so much. If you could send your presentation, we could give to the students, if you don't mind.
Yeah, I can do that. Thank you for your time and patience. Yeah.
Oi?
Svetlana, I'm very pleased to watch you teaching us. Those subjects are very important for us, so we can learn more, think in more solutions for our development here. Maybe bring some of the US technologies, the methods, a lot of new solutions to think about with your lesson.
And I'll just complete, I really like the way you teach. It's very, calmly done, and it builds up, and open construct little by little. I think that we all understand, and you speak slowly. I don't know if it's slowly, but I feel like everybody understood your English, and so thank you so much.
Thank you for inviting me, and I'm glad that you enjoyed, and I appreciate your feedback. And it's always my biggest reward for me if I see my students here and you there, that you're inspired and you think differently, and now you can do your own research. Like this was just a little bit today in a couple of hours, but then you can explore more. And world is becoming global village. That was the term I heard when I was in grad school. With the internet and technology, we can all connect and get same resources for learning, at least. Yeah.
Someday you can come here essentially, and we can come see you. And we hope someday we can receive you presentially here and have you here with us. And hopefully some of our students can go there and study with you too.
Yeah, I think Julia, is Julia still there, or Julia left? Julia?
Julia is the student from Luciana.
Yes.
Yeah, she said that she might be working with you. She's from Federal University.
Yeah, she said she's gonna come and then she had to leave earlier. So Julia will be, we're working on Julia.
She was here. I'm not sure if she was in the YouTube. Maybe she should watch from the YouTube because it was.
Oh yeah, you're right. Anyways, I want to share.
A Júlia entrou na chamada, depois ela saiu.
She entered in the call, but she had to leave, so she was in the call.
Yeah. So George was here in fall, and then if Julia goes through application process and everything goes well, she's gonna come next fall to Colorado State. So there is always opportunity for every student, if you're interested and if you can get the same kind of arrangement, we always welcome you here. Yeah.
We have to learn with Luciana how she gets the scholarship. To learn with a PhD program, so for her it's easier to get a scholarship for her students. But we'll fight for Alison to come, so he can work on his master's at Mahmoud and maybe even stay for PhD hopefully.
And you know, we do have PhD program in our program. So if you decide you want to finish masters in Brazil, and maybe like I finished masters in my country, and I think Emilia, did you do your masters in Brazil or here? I forgot.
At University of Pittsburgh, I did there.
Yeah, and PhD, right? So you could finish your masters in Brazil and then come here for PhD, or you could finish your undergrad and come for masters to the United States. So these are options, and there are opportunities for funding. So it's just a matter of making that decision and working on it. And we have good connection, because if I know you from now and I know Emilia and her students are good, then it's also for us high chance to get good students here in our grad program if you want to come here for a couple of years or 4 years. So there is always opportunity.
Thank you so much, Svetlana, my dear.
It was so nice to see you.
Yeah. A picture with you there. I think you can do it. Selfie with Svetlana. Real quick.
Oh, selfie?
Selfie from it.
Oh! Eita, deixa eu ver se não. Deixa eu ver se.